thanks so much for joining me today, Nick. If you could state your full name and title and organization, please.
Sure thing. So my name is Nick Apollo. I'm a principal scientist at Advanced Bionics.
Okay, very cool. So maybe could you explain a little bit about what your title, you said principal scientist, right? What exactly is that for those of us that don't know?
It's a good question. I don't know if I knew the answer to that two years ago. So basically in industry, in the medical device industry and any other kind of tech industry, we have a hierarchy. There's kind of a ladder of positions, there are entry-level positions, and then positions all the way up to things like director and whatever, right? So basically, fresh out of college, you might start as an engineer 1, then maybe engineer 2, and then you become a senior engineer. And then at some companies, you become a principal engineer or a staff engineer, and there could be some positions in between that. So generally speaking, a principal engineer or principal scientist might be usually 5+ years of experience and often probably some graduate school work. So, maybe a master's or a PhD.
Okay, super helpful. So would you care to describe what led you to your current job and, share any details about how you knew you wanted to do this, or did you always know? Has there been any unsuccessful work experience or promotions that led you here?
Yeah, it's a great question. So it'd be very interesting to go back and interview the 18-year-old me who it was non-negotiable. I was going to be a medical doctor. I was going to medical school. There was no questions. That was how it had to be. That was the plan. Nothing else was going to be acceptable. That being said, I did okay in math and science in high school. I think I always liked science. And so I ended up choosing to do bioengineering in undergrad. So that allowed me to include a little bit more kind of technical work. So there was an engineering component, but it also helped me fulfill the pre-med requirements. So basically, I was able to kind of get an engineering education while at the same time checking all the boxes I would need to go to medical school. And I had some clinical experiences when I was an undergrad, and I also had some research experiences. So I was able to work in a few academic labs as a part of a course that we took. So I worked in chemotherapy, drug toxicity, spent some time doing cell culture, working with rats, working with monkeys, which I do not recommend. It's terrifying for the right person. For me, it was no good. And I also spent time working as a nurse's aide in a cancer ward. So I spent a summer doing that. And that was really all meant to get me exposure to the medical industry. And so I kind of got both as a part of the undergrad experience. I'll tell you, at the time, I wasn't all that interested in the research that was happening, that I was doing. I struggled to kind of see my place in it. And I tried many different things. So I did, like I said, drug discovery, a little bit of device work, a little bit of engineering work, some cell work. I eventually ended up doing a 1-year internship, or what we call a co-op, which was like taking 3 semesters off. So I graduated 1 year later to actually do research at a company for a year. And that ended up being a great idea. So I highly encourage, engineers or anybody that's an undergraduate to look for an internship, and specifically if you can find a co-op, because that is a very deep exposure to industry work. And that's been very helpful for me. But even that being said, so I finished that, graduated, and eventually got a grant to do research in Australia. And so what was supposed to happen, I was going to take a year off school and do research in Australia, all the while applying to med school, right? This was still non-negotiable at the time. This is how it had to be. And I ended up really liking the research for the first time, and I floated around in that project too. So the first thing I started was clinical research. I did not enjoy that. I started doing some other stuff in a different lab, and I didn't like that either. And then I eventually landed on a material science lab. And this was all within a year, right? I was jumping around, trying lots of different things. The cool thing about the grant I got was I brought my own money, so my own funding. So it meant I could really do whatever I wanted. And I did. I jumped around and worked in different labs, talked to people, reached out. Eventually ended on a lab that was growing diamond in the lab and using it to build medical devices. So I was like, I've never heard of anything like that before. And the guy I ended up working with, David Garrett, super cool guy, just introduced me to a world I didn't know existed. And so I started doing material science, electrochemistry, and biomedical engineering to build a retinal prosthesis, which is a medical device to help blind people see. It was very revolutionary stuff, super exciting. And so I said, med school can wait. My friends were in it, and they were really, having a tough time studying all this stuff, spending a lot of money. I want to be careful not to discourage anybody from that profession either. It's a wonderful profession, but it, you know, at the time I'm just seeing this isn't for me. It's not adding up. And so I pivoted and did a PhD in material science, which was never the plan, you know. So I ended up
Never
staying
the
in Australia
plan.
for 5 years. Yeah.
But you fell in love with material science and research and things like that.
Yeah, it's just so cool. Yeah, I loved it.
In the most layman terms you can make it, Nick, what is material science?
So yeah, that's a good question too, which I probably also didn't know the answer to until I started graduate school in material science. It's in everything. I mean, almost every single industry, you know, would have a material science problem, and it's basically what do we build stuff out of, and how can we build it in such a way that it lasts. So in medical device, that might mean something that can last implanted in the body for 30 years. It might mean something that's safe, non-toxic, something that can release a drug in a specific amount of time. In other industries, fake meat, you know, in these lab-grown meats, non-animal product meats, those all use material scientists to study the textures and the flavors. And in the corrosion industry, you know, corrosion is a huge multi-billion-dollar problem in pipelines, in the marine industry. These are all material science problems. So basically everywhere you have hardware or a product, there is a material scientist involved trying to understand what to build your product out of or your machinery out of, how to evaluate its longevity and its quality, and how to make sure it serves its purpose over the longest possible time. And that even extends to things, you know, we're in an AI boom. Computational power is increasing exponentially. And that's all material science in a semiconductor industry. So there are a specific set of material scientists deciding what to build computer chips out of and how to build them, how to manage the power, you know, as we build chips smaller and smaller. So it's kind of everywhere. It's pretty cool.
Yeah, that was a great explanation. Okay,
Cool.
so you've shared a little bit about it, but if someone wanted to take a straight path to material science, what would that education and training look like?
Yeah, so that, you know, I would love to again have seen this. I don't know, I can't say that. I'm happy with how things turned out, but I didn't even know this field really existed when I was you know, 18 years old. So I would have loved to have known that this field existed, and if I did, I would have studied material science and engineering as an undergraduate and gotten that exposure ASAP. And so I think that would be the path, right? I would focus really hard on physics and chemistry and math. You know, those are the big ones. Material science is a split of all of those things. The great thing is that there is a huge creativity component. So I feel like different from maybe fundamental physics or math, there's creativity in those fields too, but I feel like there are even more possible answers in material science than there may be in some of the more strict theoretical science fields. But if you can, I mean, I have examples of colleagues who undergrad was material science and engineering. They worked in a material science lab on ceramics or metals or something fundamental as an undergrad. Then they do their graduate school work in material science and engineering. Then from there, you know, they'll work in like industries like aerospace. You know, that's all material science as well, right? Picking the right materials to leave the atmosphere and handle these huge temperature transitions going through the atmosphere and out into space. All these huge pressure stressors and heat stressors, thermal stressors that those ships deal with. So that would be the most straightforward path. I think you just pick it from the beginning. That being said, I think it's pretty rare to do the straightforward path. I think maybe somebody will study material science or will study physics or mechanical engineering. There are many paths into material science, and there are many material scientists that have totally different backgrounds. There are some that are pure chemists. You know, it's very diverse.
Okay, well, that's good. Let
Yeah.
me think here. Can you explain your role and the skills required for your position? So we've talked a little bit about hard skills, but also some soft skills, if you could share those.
Oh yeah, that's at least for industry, that's been some of the most important, I think, learnings I've had over the past few years. Is really know how to work with people and work on a team. So in an academic environment, I think it's focused on the individual. You know, you're the PhD student, you're the leading, you know, your one individual project. It's all about you, kind of all the way up to becoming a professor. We're still kind of the spotlight's on you. It's your lab, whatever. Which I wasn't comfortable with, frankly. I don't think there's anything objectively wrong with that, but I didn't like that idea. And so I found I was much more comfortable in industry where it was uniting for the common good. It was like the spotlight was off of you, it was on the problem, and it was you and a big team working together to solve problems. And I just love that environment. And the team I work on now is exactly that. It's exactly how it should be. It's fantastic. And so there's a high EQ component to being effective, even in these high-tech industries. So being able to communicate well, being a supportive colleague, being open to new ideas, that's going to get you further than memorizing any textbook. And so that's been very significant. And just treating people well, everything just works better when everyone's treating each other well in the team, and you can be honest and open, transparent. You don't fear punishment for bringing the truth to light. That can hold projects back in a very big way. And so the culture is super critical in that sense.
I think those are great points. And what I've found often working with people in academics or engineering or things like that, that sometimes those skills aren't as polished. And those are things that have to be worked on a little bit later in life. And so I think pointing that out now, it's great that we should focus on those things and honing those skills as well, because even if we are in highly scientific or mathematical roles, focused on research and even by ourselves quite often, you still have to collaborate cross-functionally often. And you have to be able to communicate. And like you said, share ideas and give feedback, even when it's negative, in a way that's palatable. So that's great. Let's see. What does an average day look like for you these days?
So it's quite varied, which I like. So research jobs tend to have inherent flexibility. We're in a very early R&D phase, which means the things we're working on are 5 or 10 years out. There are some immediate problems that the material scientists at my company might solve to do with manufacturing. Those are a little more urgent. So in general, what that means is there's a lot of time for exploration. So I always start my day reading research. So I'm constantly looking at Google Scholar, looking at recent publications in my field, which is electrochemistry. That's kind of the main subtype of material scientist that I am, is electrochemist. And even more specifically, it's the electrodes that go into neuromodulation devices, like deep brain stimulation electrodes or pacemakers. That's my area. Luckily for me, there's a lot of really exciting materials research in there for me to read and check out all the time. And so I start every morning reading research. That's how it goes. And then I try to do some exercise, which I highly encourage. And then the mornings tend to be a lot of kind of project management work. So I'm leading projects now, and I try to keep everything organized because that makes everyone's life easier, whether it's the technicians or engineers or even my manager. So I try to spend some time thinking about what needs to get done, what problems need to be solved, and then catching up on emails. Have a lot of brainstorming meetings and kind of catch-up meetings on specific projects. And then generally the afternoon I'll spend in the lab as needed. So I'll spend some time in the lab checking things out, setting up experiments, checking out experiments that are currently running, and often meeting with colleagues and doing things like that. But it can be totally different. It's different all the time, just depending on the needs and what stage the different experiments are at. There are some times, at least once a month, where I'm spending a lot of time preparing presentations and documents. So we have to report out our research quite a bit. So I think that's one of the big changes that happens as you become more senior in research, is you really are more senior leadership facing. And so your communication skills need to increase exponentially. So you're explaining complex topics to people who are obviously very smart and highly educated, but they're not in your field. And so you really have to hone that skill. How do I communicate these complex topics, these findings, and prepare them in a presentation that's digestible and not just rambling and equations and all this stuff. So yeah, it's quite varied, which is fun. Yeah.
That's important stuff there. I've been on the other end of that, not having the same knowledge as someone like you or even you yourself, and being grateful that you had the skills to explain it in a way that I could understand so I could make decisions. So
100%.
So what's the best part of your job?
I think just the excuse to constantly learn. I can justify learning almost anything. This is kind of the really fun thing about bioengineering and material sciences applied to biomedical engineering, is that I don't know, maybe I'm doing that for myself, but you can almost anything that piques your interest. You might find a way to apply it later. So it could be something in cancer biology. That might be something specific to a certain cell or a tissue type that responds to a treatment in a certain way, and you think, hey, we're doing something kind of similar with the drug we're interested in, or a material or device we're interested in. Maybe that'll apply. And the other is I spent some time reading about corrosion in pipelines and how they monitor the inside of the pipeline using ultrasound. And you might think, oh, maybe there was like a a certain device we could build that could monitor the inside of our gut or in our throat or our esophagus the same way that they monitor the inside of the pipeline, So I just see it as an excuse to constantly learn and keep up to speed on stuff. And that's my favorite part. I'm just an inherently very curious person, and I see stuff and I want to learn it. And I can say, oh, that's my job, Sure,
Right.
that's my job. But that's my favorite
Right.
part. The other is working with my team and the people I work with. They're just so much fun to work with. They're so smart and helpful. And we just get stuff done.
That all sounds really good. What about challenging? What are the most challenging parts of your job?
I think for me, I've always struggled to stay organized. So I think along with that curiosity might come some bits of scattered, sort of scatterbrainedness. So I think that's probably the part I struggle with. And that's one of my big goals for this year is to stay organized. So I'm starting to make use of some project management software and tools. Really, it's just started with Excel. So just tracking all of our projects and things we're working on in Excel has been hugely helpful for me to see where things are at and what things need to be done. The other challenge, I'll tell you, if you want a technical one, and I faced this challenge in a couple jobs, is trying to understand what's happening in the body, around an implanted device or after a procedure in response to a drug. So we don't have a really good way to understand how what's going to happen to our devices when they're implanted in somebody, especially for 30, 40 years. So it's kind of an emerging topic in this field, implantable medical devices or invasive medical devices. So that includes things like I said, pacemakers, deep brain stimulation electrodes, orthopedic implants, hip replacements, knee replacements. We implant them in people, and for the most part, they go well, except for when they don't. And it's often a surprise. And so we do, before it gets anywhere near a patient, we set up benchtop testing, soak them in what we think simulate body fluids or tissues or conditions. But the problem is they may not be similar enough to what actually happens in vivo. And then unfortunately, occasionally you get a surprise. And so that's the big technical challenge is how do we simulate body conditions with benchtop tests? And that's been a big challenge that I've been trying to tackle for many years.
That's an interesting challenge. I don't think I've had anybody answer the question like that yet. So.
It's a tough one. Yeah.
Okay. So pivoting a little bit, what advice would you give to students for finding a career that they really enjoy? Because hearing you talk about what you do, your eyes light up, you're excited, you get to learn all the time, you're sharing all these details. How do you find a career like that? What advice could you give?
You just got to read and learn and learn and learn. You have to just keep trying, picking stuff up until something grabs you. That's, if you don't know what you want to do, don't feel pressured to just start doing something. I think in Australia, I spent some time in Australia, and I think it may be similar in the UK. It is fairly common to take some time off before you go to college. I think that's okay, especially now with MOOCs. So these are these massively open courses, or massively online open courses. So things like MIT OpenCourseWare, Coursera, Udemy. There are a couple around. If you think there's something interesting, you can take one of those courses for free, right? So we have a friend of the family, he's got a great idea about this. He was studying one thing, thinking this probably isn't what I want to do, but I'm not prepared to fully switch majors. So I'm going to take one of these courses. I can take a single computer science course, for example, from Harvard, all online. Maybe it's for free. Maybe you pay $70-something for a certificate. I don't know. It depends what specific course and which program you want to do. You can try out a course in that degree before ever signing up for it. And that is that's amazing. So you could try a course. If you honestly check out MIT OpenCourseWare, maybe we can link it somewhere, Danielle, but you can go and just try a course in bioengineering, try a course in material science and engineering. For the most part, there are tons of free lecture notes, free videos, free homework problems, textbooks. Just try it, see if it grabs you.
I think that's incredible advice. You don't know until you know. And I'm a big proponent for internships or mentorships or job shadowing, but you just gave another idea for how to dig into something without, just jumping headfirst into it. Yeah, I love that. Okay.
Yeah, it's a nice way.
What advice would you give to students who prepare for an interview? So whether that's internships or mentorships or entry-level positions, what's your best piece of advice?
One, it might sound kind of obvious, but know your resume. So know 100% what you put on your resume or your CV. And think of it almost like slides to a PowerPoint presentation. So these are like the highlights, and you better be able to expand upon each of those things. So as somebody who's very early in their career, they may not have all that much on their CV or their resume. I think that's fine. But whatever you do have on there in terms of a skill, you better be able to explain a time when you used it. And, so I think maybe some people, you try something once and you add it as a skill to your resume. And you want to, be careful doing stuff like that, because you might be asked, to explain it in a lot of detail, and then maybe even do it in the job, which brings me to my other point. It feels like your first job, you want to stretch and make yourself sound like a fit for that position, but you may be doing yourself a disservice by kind of overselling or overstretching. It could be that it's not a good fit, and there are a lot of jobs out there. And so don't try to push the square peg in the round hole. I think it could be that if it's sounding like you're not meeting what they're looking for, just be honest with yourself about that. Be honest with your interviewer about that, and come back later. Yeah, I think just in general, being honest is only going to be good for you, because it may be that they say, "Oh, actually, you're interested in this. We have this position," and it ends up being a much better fit for you. And so even if you would have gotten, kind of stretched the truth a little bit to get that position you're interviewing for, it may be that you'll be really unhappy in it and won't go well. So I think, yeah, know your resume, know your skills, and don't stretch the truth. Probably not helping yourself too much.
That's really great advice. Well, tell me about what you think the job outlook is for material science, for that occupation or area.
Yeah, I think it's really good. I think especially, I can give you a few examples maybe, especially in the energy sector. So as we move into clean, sustainable energy, there is going to be a ton of research into energy storage. So new battery materials, fuel cells, hydrogen fuel cells, lots of power infrastructure stuff that all requires good material science. So I see that as definitely a growing industry that's going to require material science skills. And so far, fingers crossed, I haven't seen a good example of how artificial intelligence is going to replace a material scientist, somebody who's actually doing that testing. That being said, there's another interesting angle. I don't see it as a threat, I see it as an opportunity, is using artificial intelligence for materials discovery, specifically in the energy sector. So if you did find somebody, this is a new interesting overlapping of two fields, which is material science and artificial intelligence, to discover new materials for batteries, things like that. So just throwing that out there. I think in the medical space, there's a huge demand for new devices, new drugs, new products that all require material science expertise. So in the medical industry, I only see it growing there with things like cell therapies and stem cell treatments. There's like some really interesting artificial pancreas work that's happening at Vertex and some other places, all requiring material science expertise. And like I said, in the food industry, right, there's a ton of material science that goes into making food textures and flavors. The coatings industry is huge for automotive, protecting things from corrosion. Semiconductor is huge, right? We're going to be needing faster and more powerful chips. Lots of material science background there. That's an interesting overlap between material science, electrical engineering. So really, yeah, depending on how you want to pair it or match it, there's going to be a ton of opportunities. I see great outlook in that space.
That's great. And it's kind of such a niche world as well. It's probably not a ton of competition, or, not everybody's seeking out that type of degree, maybe because they don't even know it exists. So
totally. That's right. Yeah, I think maybe I'd heard of it as an undergrad, and I thought, what is that? I don't know. It sounds kind of silly. I'm doing whatever, engineering or something. But it's very much an engineering discipline.
Yeah, I definitely didn't know it existed until I needed your services and met you. So exposed me to a whole new world. It's not on my list of questions, but I'm going to throw one at you. You work remotely primarily, correct? Or you have in the past?
Yeah. So during the pandemic, I was a lab scientist at my first job, which was Dexcom, which is the glucose sensor company. My manager was very cool, and there was a lot of time spent analyzing data and preparing presentations. And he said, if you don't want to do that in the office, don't do it in the office. So he was already pretty cool before the pandemic, but the pandemic hit and it was like, nobody's coming in, right? So As soon as that happened, we went fully remote. And I think this was if I had to pick one positive of the pandemic, we're forced to make lemonade, right? It was basically showed companies that your employees can work from home and you're not going to shut down operations. You're not going to fail or close. It's fine. Your good employees are going to get their stuff done. They're going to waste less time commuting, probably be less burned out. So I think it really showed, at least my company, that it was fine. And then from there, it was hybrid. It was kind of like go in as needed. If it doesn't make sense for you to go in, don't, because we still don't really know what's happening with this pandemic thing. Let's just minimize risk. And I think from an environmental perspective, I believe in it very strongly. Why do you have people just driving and doing all this stuff for no reason, just to sit at a computer if they could do it at home? I don't get it. But for now, it is mostly remote. Yeah, it's kind of transitioning. I like to work in the lab, so there are days that I'm happy I get to go in. But for the most part, yeah, it's remote work, based on the nature of the job for now. But it can be very different for different types of scientists. Some are definitely full-time on site, 100% in the lab.
Okay, thanks for clarifying that. All right, so my final question would be, are there any opportunities with you or your organization for any internships, paid or unpaid, mentorship, or job shadowing?
Yeah, totally. So we have a paid internship program at my current company, which is fantastic. We have an intern in now who's just amazing, super smart, accomplishing a ton of work, learning really fast, wonderful, a lot of enthusiasm. But we kind of take one at a time, and they tend to be masters and above in my specific department. That being said, I think we've had interns who maybe, I'm not sure if they're people who are like in an early stage of their undergraduate degrees or immediately have finished, but my understanding is that many will have had graduate degrees or have finished their undergrad to become interns. That's not the case everywhere. Like I said, my first one, I was 2 years into my undergraduate degree, and then I took a year off to work as an intern at a company. So those are out there for sure. But in my experience at my current company, it tends to be people who are a little more senior. But yes, that opportunity is there, and it's a wonderful program. It's fantastic. You're going to learn a ton of stuff. Job shadowing, I'm totally happy about. We're in Valencia, California, so I don't know if that's an easy one to shadow, but the opportunity is there. Absolutely, I'm happy to do those types of things. Sure.
Okay, and as far as mentorship, if there were any students that were really interested in what you've shared today, would you be willing to talk more with them in the future?
100%, anytime. Happy to talk as long as they want me to. They might just want to hang up after 15 minutes or something, but absolutely happy to. Yeah, so I was saying before, I wasn't really sure who to talk to. I kind of struggled a little bit with mentorship at various stages of my career. And LinkedIn was kind of a game changer for me. I was able to search out more senior people and just ask them what's it like to work at your company and do this job. I highly encourage people to do that. I haven't encountered, maybe some people will ignore you, but I haven't encountered anybody who wasn't happy to chat with me for 30 minutes and tell me their story. I just did it recently. So I've had PhD students reach out to me. That happened many times. I've done that maybe 10 plus times in the last 5 years. Somebody finishing grad school and said, hey, what's it like to work at this company that you're currently at? Et cetera. Happy to have that conversation. And I did it recently for a more senior person. He was working somewhere that I was interested in, and I reached out and we chatted, right? He's a much more senior person than me. So LinkedIn's kind of amazing in that way. You can reach out and just chat to people.
I completely agree. I'm a big fan of LinkedIn, and I kind of sing its praises all the time when anyone will let me. So
yeah, it's awesome.
Okay, well, Nick, I think that's all the questions that I had. Is there anything else that you'd like to share, or anything we might have missed?
I don't know. I don't think so. We covered it. It's pretty good.
Covered a lot. Okay. Yeah. Well, I look forward to talking to you soon. Thank you so much
Absolutely.
for your time.
Okay. Yeah, thanks. Great talking to you.